Our plan is to fill out this whole page, just so first of all we can write it down and remember everything, and second of all it'll all be in one spot so that you can study for your test on Wednesday. First is segment addition postulate. Can you just draw a segment on your paper? We're going to label that, say, ABC. Segment addition just says the little segment plus the little segment equals the length of the big segment. So length of AB plus length of BC will equal length of AC. Angle addition postulate, same thing, only with angles. We've got two angle measures. If we take those two smaller measures and add them together, it will equal the measure of the big angle, which we'll have to name something. The midpoint formula, which you should have memorized by Wednesday. Just averaging the x's and averaging the y's. The distance formula, which finds length, reminds me of a squared plus b squared equals c squared. And then in the parentheses, we just subtract the x's and subtract the y's. This year, we're going to skip the formulas for circumference and area. Those will come up later in the year. How do we name things? First of all, we name a point with a capital letter. We name a line using 2 points, so 2 capital letters, making sure that the symbol on top looks like a line with the arrows. We can also name it, if we don't want to use 2 points, we can label it with a lowercase letter, maybe line lowercase k. A plane is named by 3 triangular points. Or we could use sort of a cursive or a script or a bold letter. But that one should be capital too. The segment is just named by its endpoints and just has a bar on top. Array, use the endpoint, and then any other point that's on the ray will work. Always the endpoint comes first with the one-sided arrow on top. If you ever see 2 letters stuck together like this, all it means is the length from G to H, the length of the segment. So GH, maybe it is going to have you do a distance formula. To name an angle, we can name it by its vertex, angle V. If there's more than one angle V, you probably want to throw in some more letters. Always making sure that the vertex is in the middle though. Collinear means same line. So you can have lots and lots of points that are collinear. Coplanar means same plane. You can have lots and lots of points on the same plane, or even lots and lots of lines on the same plane. Intersection. We learned about 3 types of intersections. First is 2 lines intersect at a point. 2 planes, which are infinite, intersect on an infinite line. And a line stabs through a plane at one single point. A postulate is a rule that we just accept without proof. It's just a rule. If you have 2 segments that have the same measurement, you can say that those segments are congruent to one another. Same with angles. If you have 2 angles with the same measurement, we say that those angles are congruent to each other. If you were to draw yourself a midpoint, I always have to put the tick on there, because that tells me that that midpoint has split that into 2 equally lengthed pieces. That's what a midpoint does. It splits it exactly in half. Segment bisector is the same idea, only we're cutting the segment in half, tick, tick, with something other than just a point, but those 2 sides would still be the same length. An angle bisector, again, gets cut in half, not tick, tick, but swoop, swoop. just indicates that both of those angles have the same measurement, angle bisector. You should know acute, right, obtuse, and straight angles. Complementary 90, supplementary 180. Just remember that it's two angles that add together. Two angles. It's a pair of angles. Adjacent angles. They're good sharers. They share a vertex and a side. A linear pair. Always looking like this. Two angles that together make a straight angle. They're adjacent to each other. Vertical angles across from each other on an X. Turns out that those angles are always congruent, vertical angles. Polygons. They're always flat and closed and made out of straight line segments. And something about segments connect to each other. Only two to each segment, one to each side. So each vertex connects to two other segments. Convex and concave. Maybe we'll just draw one. Here's a convex. Here's a concave. And that's where the bear goes, in the cave. Equilateral. Something that has all equal sides, like a rhombus. Tick, 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 tick. Equiangular, something that has all equal angles, like a rectangle. Swoop, 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 swoop. A regular polygon, my favorite being a hexagon. A regular hexagon, such a pretty shape, has all congruent sides and all congruent angles. It's a regular polygon, both equilateral and equiangular. And finally, it probably wouldn't hurt to write these all down one more time in order to study or practice. You'll need to know all of those.